Let me, yeah. Prediction task, classification task, and clustering task. Okay, prediction, we use regression for prediction. Classification, there are different algorithms, different techniques, and clustering, again, there are different techniques. So I will focus more on classification technique today, and if possible, then I will, ask every one of you to come up with some data set, and if you want to discuss it with me, that how classification will be applied on your data set, or it is possible or not, you can discuss it. Otherwise we can go ahead with this. So classification technique, what is the basic idea behind it? So suppose I will try to quote few examples, like uh, suppose we have more than, I guess, 600 districts in India, and we have to classify which district of India is. Let's say there are three categories, like developing nations and thing. Developed districts, developing, and undeveloped. So I'm not from the social science background, so you can choose whatever you classes you want to choose it. So you can say that developed, and there are three classes. So we have made three classes, and we have to put all the districts of India under these three classes. So this problem is now classification. So we have some data set related to districts of India. Say you can say electricity, internet penetration, or say literacy rate, gender ratio. There are hundreds of factors which you can choose, on the basis of which you want to categorize under these three categories. Okay, so what classification techniques will do? Say you have a data set of, say, 100 districts right now. Okay, you have the data set of 100 districts. I said I have specified the parameters, like whatever parameter you want to choose, it's up to you. Electricity, transportation, education, food supply, whatever the factors you can choose, and you have categorized these three things. So since this data is going to be labeled, okay, so we are applying classification techniques. If you don't have this data and you don't want to label it, then this problem will become clustering. Okay, someone's mic is open. I will request that please keep your mic off, all the participants. Vandana ji. Yeah. Okay, so I hope this problem is clear. We have to put all the districts under these three classes. This is the problem here. And now what we can do in the classification. So I will put both the things here, like how to apply classification and how to apply clustering here. So what you will have to do, you have 100 data set, as I said. Okay, and in the table form. So we are dealing with structured data set right now. You have the columns, transportation, electricity, education, whatever the factors you want to categorize. And suppose for 100 data set, you have classified, you have put label on it. So you have district number 1, and you have all this data, and you have put it in the developed section. Developed, let me write something, developed. And second district, again some the values, and you have put it in undeveloped. Third district, and you have put it say again in the developed. And fourth district, you have put it in under developing nation. So you have categorized, because the data set is small, so you can actually label it. Okay, so that for the other 500 districts, or let's say for the other 5,000 districts, you want your program to do all the things. Okay, whatever you are using, software you are using, I will try to show few of the options today, that how to go for it. for other 5,000 you want it to automatically run. So this is applying machine learning or data science is it. Okay, so I hope the problem is clear. You have 100 data set with labels, and now using machine learning algorithm or using data science, you want that for other 5,000 districts it should automatically classify, or it should put in three classes for these 5,000 data points. Okay, so what classification problem will do now? You have to choose one technique. There are different techniques, as I said. Let's not go into the mathematics behind it. There are the technique. One technique is called as SVM, support vector machine. One technique is called as ANN, artificial neural network. One is called as decision tree. So suppose we have three techniques, and now what we want to do, we have 100 data set of 100 districts, data sets for 100 districts. Okay, uh, now what this classification technique will do, uh, you will we will again have to divide this 100 data set into two part, 80% or 80 and 20%. Okay, and whatever the number of the data set, 80% and 20%, this is a common phenomena. What it will do with 80% data, we will train our model, we will call as training, and for 20% we will test our model. Okay, and what is the models? These are the models: SVM model, ANN model, and ADT model. So let's as I said, I will not go into the mathematics behind these techniques, but just you have to suppose that we have three classification techniques which we can apply on our data set. Okay, and what do you mean by training? So by training, we mean that we will train our model. We will train our model that if you find that these are the values of the parameters, like if say education is more than 80%, if electricity has been covered more than 75%, and these are the factors, then we call this district as developed district. Okay, uh, I will please participants keep yourself muted. Okay. Uh, so we have these things. We have this data set, and we are trying to use classification techniques. So please listen carefully. If you have doubt, you can ask after this example. Okay. Uh, so we have this data set. Out of these 100, we will use 80 data points for training and 20 for testing. Okay, so 80% training means the model will learn. So suppose we are applying SVM model, then the model will learn that if education is this, if transportation is this, if electricity is this, if food supply is this, then this district is developed. And again, this if it is less than 50% like education literacy rate is less than say 50%, and if this is electricity supply is less than 60%, then we will categorize it as undeveloped. And if it lies between some, you have to decide the parameter, the value of the parameters, that if this is between this to this range, then this is developing. Okay, so you have trained the model, like you have set all the parameters, and you have trained the model that if these are the values, then we will consider this as to be developed, and this is this. So our model will be trained, okay, with 80% of the data set. So out of 100 district data, 80 district data will be used for training purpose. Now suppose we say that our model has been trained with this 80% data set, or say out of 100, 80 data set has been used for training. Then we will test 20% the model with this 20% data set. Okay, so now we will not give this label to our model, and we will ask okay, so this is the district number 81. Now this is the education, this is the literacy, this is the electricity, this is the internet. Please classify whatever you have learned, please classify this district under these three classes. Okay, so our model will classify it under any of these three categories, and we will say that if it correctly categorizes the model, then it will be treated as accurate, and if it it does not classify it correctly, then we will say that it has error. Okay, so accuracy and error. So if you have accuracy more than say 90% or 80%, 80%, then we will say that this model is good, and you can use it for other unknown 5,000 districts. Okay, you can use this model to classify for another 5,000 districts for which we don't have any idea. Okay, so for other 5,000 districts, or say other one, if you are talking about cities or towns, then say so, or villages. So we have village data. Suppose we have village data, and you will say that for classify for another 1 lakh villages. Okay, so the if because you have tested the model, you have trained the model, then it is very high, with high probability it will classify very accurately. Okay, so for another 5,000 districts. So this problem is classification. So suppose we have three models. Now how the research paper will go? So suppose you have data set, and you are trying different models. So suppose I give you that try SVM, try ANN, try DT, decision tree, and suppose SVM gives 80% accuracy, ANN gives 90% accuracy, and DT gives say 70% accuracy. Then obviously we'll say that this model is good for this classification, and you can go for this research work. Okay, I hope this is clear. Now you can ask any question if you have any doubt till now. I've tried to make it simpler. What do you mean by classification and how it works? Any doubt? No? Okay, so let's again recap this, whatever I have you know gone through. That this is our model, and you have a data set. Okay, you have data set. You will train the model with 80% data set, and you will test the model with the remaining 20% data set. If if accuracy is higher, say more than 80% or 90%, then we will accept the model, or otherwise we will change the model. We will try to use another model which gives more accuracy. And after you are satisfied with the accuracy rate, then we will use this classification model to use it for unknown data set. Okay, so if for few data set, you will have to use the model to use it for training, then testing, and then for applying for unknown data set. Let me go for few examples. For this demonstration, I'm using MATLAB, but I will ask in the future session, I will try to cover some open source tools. So suppose I will use this. You will understand it very easily. Please let me know if you don't get it. I will take some other example. So next, I will just show you how it comes out. Load example data set. So I'm taking an already existing example data set. So for this, we have different example data set: breast cancer, types of glasses, thyroid, fine vintage. So suppose I take this example, iris flower. I will explain what this iris flower data set is. Next. Next. So you can see in this iris flower data set, we have 104 samples. So let me just show you what this technique is, and now you can think of a problem related to your data set. So this iris flower data set has three kinds of flowers. Uh, a, there are four things in a flower. So we have petal length. So you must have seen flower. So if this is a flower, and these are the green thing here. So these things are called as petal, and these things are called as sepal. So we have petal length, petal width, sepal length, sepal width. And based on this, we want to use this classification technique. Petal length, petal width, sepal length, sepal width. Okay, and suppose this is some value, say 20, 15, 12, 10. And this is there are three kinds of flowers. So the data set contains the flower Virginica, Setosa, and Versicolor. There are three flowers. Based on these, we have this data set. So we have 104, 100, say 100 data flower, 104, and say 35 of one each. Okay, you can make it count like this. So each flower has equal number of samples in this data set. What we will do in this problem, again 80% of data will be used for training, and 20% data set will be used for testing. And with this 80%, if the model is accurate, we will test the model that uh, if this model is able to predict the category of the flower or correctly or not. So for validation, 15%. For suppose don't want validation much, I will not discuss about this. So for training, 80% data, and for say validation 5%, and testing 15%. Forget about this validation right now. So next, next. Train. Now training has been started, and now we can see the results here. So if I say performance, so you can see that this is error rate. So error reduces. This is the graph. So 10 to power minus 1. That means key 110. So the accuracy rate is quite high. I will show you how to see it very clearly through this uh, this curve. Okay, and this curve, you see this ROC line. We'll talk about this ROC line later. But this straight line indicates that the accuracy is quite low, quite high. More it is upper in the upper direction, more accuracy is there. Okay, uh, there is a confusion matrix also that again I will explain. That how this accuracy rate is measured here. So this you can see if you are going for classification problem, you can come up with these results for your problem, and you can put it in your research work. Okay. I hope this is clear. If it is not clear, then I will not move ahead. I will explain this thing only. So please feel free to ask any question. If you don't have understand anything, then again I will explain everything again. But I want that you should come up with queries and ask any doubt. If you have not understood it, I will explain it again through different examples. Okay. Any question? Dr. Garima, if you want to ask any question, you can unmute yourself and you can ask. No questions. So this is classification problem. I will again explain. You should have some data set, and you should have some labels in it. Okay. So suppose you have data set where these are, say, are the values, and you have to choose one column of data which you can call it as labels. Okay, so for say election data, you can put some, two categories. So suppose you have election data of US elections, you will find it in on the net, and you can categorize it under two classes, say Joe Biden in the previous election and Donald Trump. So suppose these are the parameters, then it has this this category of people have voted for Biden, and the parameters with the people with these parameters have voted for Trump. Okay, so you have this data set of say 1,000 people. So in you will put this model into classification model, and the classification model will categorize it in the two categories, 80% and 20%. 80% it will use it for training, it will train itself, and with this training it will test that whether this I have learned or not, the model has learned or not. With 20% it will be used for testing, and after that testing, it can be applied for some unknown data. Okay, so what is the significance of classification? uh, After the training and testing, if the accuracy rate is higher for that model, uh, then this can be used for any unknown data, and if the accuracy rate was higher, it is with very high probability it will classify uh, accurately for the unknown data as well. Okay, so this is the classification technique, and it should be used for high data with many rows, because if you have very small data set, then it is of no use to apply classification techniques, because it should be used for data set which is very where the rows are very large in number, and you are not able to do it manually, because if for the smaller data set everything can be done manually, you can actually put like this is belongs to this, it belongs to this, it belongs to this. Okay, but for a very high data set with very large number of rows, classification technique will work. Okay, so I will just explain few other examples whether it can be available for in computer science also. So suppose image classification, or what you must have heard about face recognition. Yes, Garima ma'am, you can ask your question, you can unmute yourself.
Sir, good morning actually. So I want to ask here, is it like only functional for dichotomous dependent variable, or we can go for multi dependent variable?
Yeah, you can go for any kind of variables. It is not specified that it should be used for particular type of thing. So yeah, techniques will be different. There are because I have talked about very simple classification technique, there are hundreds of categories of classification techniques for
Okay.
variable different variables. So based on your data you will have to select your model. Okay.
So if I'm having more than three categories,
Yes, yes,
right,
yes,
and
yes.
then I want to check the predictive accuracy.
Yes, yes, yes. You can
So
do
there
it
are.
for, even there is called multi-class, multi-label classification. So
Hmm.
suppose you have a data set, a value, one thing which has multiple categories. Okay, with the
Hmm.
same value, it can have multiple categories. So suppose you want to categorize as developed, undeveloped, and you have some other categories also for the same data
Hmm.
set. Then you can
Hmm.
do for that also. Okay.
Right. Okay. There is a follow-up question for this. As
Mm-hmm.
we use in, like, I have tried discriminant and logistic regression in SPSS.
Mm-hmm.
So there is, like, here, and Etel has mentioned about the good range of predictive accuracy. So if
Mm-hmm.
it is like, if your predictive accuracy is coming above 75%, then
Mm-hmm.
only the predictive accuracy for the holdout sample, with the holdout sample, if it is coming above 75%, then it is a good model to be
Mm-hmm.
taken into consideration. Then they for come up for 60 to below 75,
Mm-hmm.
is like moderate predictive accuracy. So
Yes, yes,
does
yes.
these hold true for this also? Like,
Yeah,
or we have some other
mm,
specification?
yeah, that is correct. Actually, below 60%, it is not recommended. Even you can consider that this is a not the problem is not for classification problem. So you can actually, so accuracy should be higher, because 60%, below 60%, it's not acceptable actually. Okay, maybe it can be acceptable for uh, few kind of data set where these things, these variations are acceptable. But specifically, for example, if I take example of computer science, then 60% is very bad. Okay, below 60% is very bad. But yeah,
Okay.
you can say for election data, if 60% might be a good number to come up with. Like it can be better than exit poll and opinion poll, because prediction, if your prediction rate is higher. So maybe in few kind of problem for say for production, for commerce data, 60% must it should not be that much good. Okay, for taking
Okay.
decision. Okay, so
Hmm.
higher the accuracy, they will,
Yeah.
yeah. So that's why we it is recommended that the model should be changed. Okay, so we have different kind of model, as I showed this in this example, MATLAB example. This model is ANN model, what we call as artificial neural network. So I have used this neural network pattern. So this is a neural network based machine classification. There are other models also, as VM, as I said. So you
Right.
can go for different other kinds of model also. Okay.
Okay. One final follow-up question.
Mm-hmm.
uh, when we run discriminant in all these things in SPSS, so the basic idea is they go for Mahabolini's distance from the
Mm-hmm.
centroid, and then they categorize and
Mm-hmm.
put it into different category. So what is
Mm-hmm.
the mechanism here? Which test go for like categorizing the, or like, is it the same? We go for the distance evaluation from the centroid, or some other
Yes, yes, yes. So
mechanism is
centroid,
used?
centroid is basically that you are talking about is mode of clustering.
Yeah.
Here this is a simple distance, Euclidean distance, and other distances will work. Okay, so yeah,
Okay.
classification is a little bit different from clustering. So you are talking about that clustering technique. So I will cover it later. But yeah, there are different mechanisms for computing, Lagrangian distance, Euclidean distance, and other. There are hundreds of them. Okay, and you
Okay.
have options. So you have more options in MATLAB and other packages rather than SPSS. SPSS
Yeah.
has limitations, but
Yeah, we have there like we I have two or three tests where like
yes,
the
yes.
most used test is Mahabali's distance from the
Yeah,
centroid test.
in fact, I don't recommend SPSS for machine learning based things. SPSS should be
Okay.
used for basic statistical things like statistical tests and other things.
Hmm.
For machine learning, I don't recommend it. If you can go for R, then it is good. And if you
Right.
don't want to code, because most of the participants here, they are not from the coding background, they are not comfortable
Hmm.
with that. That's why
Hmm.
I will choose only those things which where drag and drop will work. Okay, you just have to drag and drop things. So this is the basic problem, that yeah, if you can code, then go for R or Python. Python is the best for machine learning. There's no comparison about Python. And SPSS has several limitations for machine learning. Yeah, that I can
Right.
say.
Okay. Thank you.
Okay, so as I said, it depends on the accuracy, because 70%, 5% accuracy is very good in case of, I say, political science data or any other social science data, but it cannot be good for, say, computer science data. I will take an example. You must have heard about self-driving cars. Okay, self-driving cars in US. So self-driving cars is again a classification problem, because it has to classify. So car is going in the on the road, and it will have to classify the things like, okay, so this is a human, this is a car, this is a truck, okay, this is a, this is a road, and these are the boundaries of the road, divider. So there are several classifications. So this car, the software in this car will classify everything. Okay, so the accuracy should be higher. So suppose something comes up like, this object is going on the road, and if it is not, the accuracy rate is not higher, so it classify it as a 75% as a car, and say, or maybe 60% as a car, and 40% as a truck, then this is going to be big problem for this car. Okay, so the accuracy rate in this self-driving car should be more than 99%. Okay, that's why depends on the data set, and it depends on the problem. Like again, this is a completely classification problem. Self-driving car is a completely classification problem. Face recognition is a again computer science problem, where it is a classification problem, because we have several faces and we have different features on a face. Some eyelid, retina, your lips, and face shape. There are hundreds of factors on our face, and based on it, it will have to classify whether this face is of this person, or this face is for this person. This is not a two class classification or three class classification, because I have talked about this three class classification in my previous example: developed, undeveloped, and developing. But in case of face recognition, this is a million class classification. Okay, so for that, it will have to train thousands or millions of data set. Okay, so this is a big classification problem, face recognition. Self-driving car is a big problem. But for for data sets in social science, it can be very much acceptable, because you have to make some policy. So why, you must have heard about, if you are from social science background, Oxford University have started, say, AI for governance. If I'm not wrong, they have launched several projects for also. So in governance also, it is very important to use AI. And AI hereby means, again, machine learning, what I am talking about. And in machine learning, again, classification. So indirectly, this is in the governance. So if I say classification problem in governance, I will not be wrong, because most of the problems in governance also is a classification problem. So how it is a classification problem? Because a government has to take decision based on something. So suppose Ministry of Road and Transport, they want to make sure that a new expressway should be set up between these two locations. Then if they want to the help of AI or classification based on different data set, based on number of people moving in from this city to that city, based on you, what is the economy between these two cities, and a different data set, it will have to make policy. It will have to decide, yes, should go for this road or not. So this is again the classification problem, where they have two classes: road should be there or road should not be there. Only two cases are there. Okay, so with suppose with data set, they come up with that, yes, 60% accuracy. Yeah, the model says that you should go for this road with 60% accuracy. Then the policymakers will have to decide, yes, 60% is a good number and we should go for this road. But if it reduces, say, less than 50% or 50% or 49%, then maybe the government can say that no, we should not go for this. Okay, so for policy making also, the classification problem is there. If we have some data set, that's why data is now playing very important role in governance. And they have put, as I said in the previous class also, all the data set, all in India, they are putting it in data.gv.in. And I will recommend all the social science people, especially all the social science people, you must go to this website, and download data set from these different departments, and apply it for say, classification or prediction problem. So as I said, there are two kinds of problem which you can do. I have discussed today classification, and prediction regression. As I said in the previous class, you can predict something like, for agriculture production. I have already downloaded it, but I will show you how to download if you are working in the agricultural data set. Then this is a site, Faustat. I will show you how to use this data. Faustat is the site name. You can go for this if you are working in the agriculture data set, and you will find different kind of data set for almost all the fields. So click on this export data. So this has 250 245 data points. So say I say production, crops and livestock products, and here you can download your data for different countries or maybe for India also. Okay, if you want to work on only Indian data set, but if you want some comparative study, you want to see how India and China is working and you want to compare, then you can go for that. And here you can see different parameters are there. So suppose you want to download area harvested and yield, or if you want single variable analysis, then you can select only one field, yield, as I demonstrated in the previous class. So yield and year only, then you can select these two things only. And here say crop, or maybe particular crop only. So let me take only one crop here. If you want to go for all the crops or a particular set of crops, then you can go for that also. Let me select the only wheat, which I discussed in the previous session, wheat, and I want it for all the years. So from 1961 to up to 2020, and here now you can download it in different formats. So if you want it in Excel format, you can download it here, download data. Okay, so you can see, and now you can apply this data set for different kinds of analysis. So for this data set, I would say that you can apply for you cannot apply classification for this data set, but definitely you can go for regression, or you can say that prediction, that you have the data set and now you want to predict that what will be the production in 2025 based on these two data for wheat. Then you can try this thing. This is not going to be accurate, as in the previous class Pankaj has said that you have different parameters which determine the yield of a wheat. But I just want that based on this data, and we want to predict the yield of wheat for this data set, that then you can go for it. Okay, any doubt, query till now? No. Okay, now let's come like how to apply it, because we have covered several theories. But suppose you want to go for it, then how you can do it for your data set? Okay, so there are different tools. You can start very basic things from the Excel, Microsoft Excel. Okay, and I in the previous session, the recorded session is also there. You should pre-process your data, or you should clean your data before going for some analysis. So I covered Open Define in the recorded session, which is there on the portal. So can go for Open Define for data cleaning or basic data cleaning. Uh, some analysis can be done on MS Excel, but not the detailed analysis like classification clustering. You cannot do it in Excel. Uh, you can go for SPSS after that if you don't want much of coding. And then you have if you want to go into more deeper kind of analysis, then you have to switch from these two things, and you will have to go for some coding languages, R or Python. But as most of the participants, they are not from the coding background, so these things goes, this will not work for them. But maybe few of them, you are from management and commerce, you can definitely go for these things. uh, but for others, I would recommend that you can go for MATLAB, where you don't have to code anything, or you can go for some open source tools like Tableau. And again, this is not a open source license, but there is a parallel version of it, which is 9. So this is recommended for those people who want to work on machine learning or data science or AI, whatever you want to say, and you don't want to code anything. You're not comfortable in coding, and you want some open source tool, because MATLAB and Tableau, these are not open source. Either you will have to use the pirated version of it, or you will have to use some trial version of it. or you will have to pay for it. Okay, so you have these kind of options for this these things. For Nime, this is an open source. Yes, Garima ma'am. Yes, ma'am.
Sir, yeah, am I audible?
Yes, yes, ma'am.
So can you please suggest some of the open data source for if like a scholar want to work on developmental economics related to the economic parameters of the different institution? One is like this I'm asking. Second is if I want to, if I am from the HR and I want to know the HR parameters of the different organization, any data source available for that?
Okay, so as in the previous class also, I specified that there are different ways of searching data, data.gov, one is there, and dataset research.google.com. So this is a site where you can put your data. Suppose human resource, you will have to search for it, and these links will come up with. Okay, so again, this is a good way of searching data. Dataset search.research.google.com. You can directly go for Kaggle also. Kaggle will again contain different datasets, and here you can buy it. This is whatever you want to search for. Okay.
Okay, I just want to add here since like my core area is entrepreneurship. So we have GEM, Global Entrepreneurship Monitor,
Mhm.
which provide a very and like rich data for the monitoring of entrepreneurship in across the globe. So do we
Okay.
have any like if you can suggest us some specific site like these are I can understand these are the
Mhm.
common sites from where we can get the data,
Mhm.
but any specific site?
Okay, I will have to search exactly for you can ask you can put your specific area on the Telegram. I will recommend it because I'm not from that area, so I will have to search for it, then I can recommend it. Okay.
Okay.
All right. So as I said, this Nime is there. So if you want to go for, you don't want to go for coding, as I said, how to go about, because we have covered several theoretical aspects. And suppose you are able to download data set related to your field, and you want to go for AI or ML or data science, then these are the options. For very basic analysis, these are good packages, MS Excel and SPSS. If you are comfortable in coding, then R and Python are recommended, and especially for AI and ML, Python is strongly recommended. Those who are comfortable in coding, but those who are not comfortable in coding, then you have these options, as I said, MATLAB and Tableau, where drag and drop things will work. But these things are paid softwares. Either you will have to use a pirated version of it, which is not actually recommended for the teaching community. But yes, if you want to go for some open source which is free and which have all the features, then as I said, this Nime is recommended for them. You can actually download Nime from site. You just have to Google Nime, KI9, and you can download it in from this site. Okay. So it has almost all the features. I will upload the recorded session on the portal so that you can see about Nime if you want to start with it. And it is free. You can download it, and you don't have to code anything. You have to drag and drop things here. And you can see different tools are there. So if I go on this analytics, there are different types of classification, and even you can say this clustering technique. So these kind of clustering techniques you can apply by just dragging and dropping things on your and you can use it for your data set. Okay. I will not cover it today in this live session because it will be too much for most of you. But yes, if you have any doubt regarding today's session, if you are not able to figure out what exactly classification is, then you can ask. But you must be sure that what you should look at your data set, and you will have to identify that what kind of things can be applied on your data set, and what is going to be the outcome. As I said, every data set, taking out some kind of pattern or some kind of intelligence from your data set. This is the basic goal of data science, and it should be useful for some policymakers, or it should be useful for making some kind of product. Then this analysis or will be useful. Otherwise, just going for any kind of analysis on your data set, it is not going to work. Two, yeah, participants have raised hand. Please ask your questions.
Sir, are you talking about the 80% of training and 20% of testing? It's depend on our study or it is rigid?
It is done by the software, so you don't have to do anything for it. Okay, so 80% and 20% you don't have to choose. Yes, there's an option, as you can say. You can see in my this example. uh, I will just explain it very quickly. So loading example data set, iris flower, import, and next you can see I have this option here. I can increase the testing. So suppose I want that 30% data should be used for testing. I will reduce this one. So you can see this thing I can change in this software. But it is the standard thing that it 20% data should be used for training, and 75 or 80% should be used for training. So that's it, and the machine will do. So this software will do the training part next, and as soon as I click on training, then it will use this thing. Okay, now you can.
Okay, thank you,
Yeah,
sir.
yes, yes. Now what is the use of classification? I have explained it. After training the model by 80% and 20% testing, now for unknown data, if your model is able to predict it for unknown data, then this is a real application of this classification problem. Okay, so suppose even I will quote one example of the attendance software. One of our student made an app for attendance system by clicking the picture of the class. Okay, so it has the app the student took hundreds of pictures in the class, so that the model will be trained. It will able to recognize every face, and it will able to categorize under different categories. So there, if there was 50 student in my class, then this is the 50 class problem. So the student took 100 pictures. He feed that into a model. The model was used for training 80%, 20%. And again, in the next class, if if I clicked the picture, then it will automatically took the attendance. So this is the real application in the computer science. But as I said, in governance, in economics, people, there is a huge, there are hundreds of application in economics. There are hundreds of applications in policy making. But you will have to understand these things. You will have to understand the basic concept of classification. What Because by classification, simple word, we cannot figure out what exactly classification. We will have to understand from the data set point of view that how this data is going to be used for, and how it is going to be useful for policymakers, or maybe for some software, or for product launching. Okay, any other query? Other participants, please, you can also ask your questions. Specifically political science people, you can come up with your data set if you want to discuss it in the class, in the live session. I can, if you, or even you can share your data set with me, so that I can give some input on your data set. Okay, but you will have to find out. I have specified different sources also. If you have not find out data set related to your field, then go for different sites, say data.gov.in or Kaggle. Find out data set related to your field. See the data set, and try to find out that if some kind of regression or classification can be applied on your data set or not. Otherwise, you can share it with me, and we can discuss it. Okay, on Telegram. Okay.